Now, one example of a solution or homogeneous mixture that involves dissociating ions would be what we call an electrolyte. To make an electrolyte, you create a solution or homogeneous mixture of ions with water. And those ions could be an acid, they could be a base, or they could be a salt. But the point is that they are ions that are nicely dissociated in the water so that you can't see them. It's all in one phase, just kind of looks like water, and they've distributed those ions throughout. Because we have ions distributed throughout the solution, it has the ability to conduct electricity. So when you see the word electrolyte, think electro. That means that it conducts electricity. Okay? So why is it able to do this? Well, it turns out that in that water, once you've dissolved those ions, you have cations or positive charges, and you have anions or negative charges, and they're all floating around. The ions that are dissolved in the solution are what give it the property or the ability for electricity to travel through the mixture. So in other words, if I have a beaker, put some water in it, drop some salt in it, well, all of a sudden, now I have all these charges here. And these charges are going to give the electricity the ability to move around. If we had pure water, so another beaker, and put some water in there, but there's nothing in here, no positives, no negatives, no ions. It turns out that pure water is not conductive. No ions means no conduction. So if you have pure water, what we call distilled water, it will not conduct electricity. You have to add ions to get conductivity or conduction of electricity. And if you do that, it's what we call an electrolyte.